Today I will show you how to create a WIN32 window, the foundation of every game, step by step in C++. This will be your first real building block towards a custom game engine. First thing in VS Code, make sure we have the official C++ extension installed. Navigate to the Extensions tab, type C++, and install if needed. Finally, let's create our first C++ file. We call it main.cpp. Inside this file, we will add the Windows header so we can see all functions and symbols of the WIN32 API. Next, we write the entry point of our game, called winMain, and is invoked by the operating system. It returns an integer so we can indicate a runtime error. The mandatory WIN API calling convention indicates how this function receives the parameters on the stack. The first parameter, hInstance, is a handle to your actual executable, and we will need it later when invoking other WIN32 API functions. The second parameter, previous instance, is never used since the 16-bit era and always 0. The third parameter is a string of the command line, useful to parse for startup arguments. The last parameter decides how the window is initially displayed, minimized, maximized, or normal with the desired size. Normal is the default here. We continue with the body of the winMain function. First, some local variables to hold the dimension of our window and the name of our window class. The window class is defined next with the following attributes. CB_size. It is mandatory and can be retrieved by applying the sizeOf operator on the actual struct. Then we have LPFN windproc. This is the pointer to our message handling function. For now, we just use the Windows default procedure here. The next attribute is hInstance, and we can just pass the parameter from above. The final attribute, at least for now, is the class name, and we assign it the variable we defined earlier. Next, we call register class, so Windows knows about our class when we use it later. By calling the function createWindowX, we, ask Windows to actually create our window. The most important parameters for now is the name of our registered window class, the actual name of the window, and some styling and sizing parameters. For now, we will keep it simple and explore more of the many options later in the series. We then check if the creation of our window was successful, and if it was, we call showWindow and updateWindow. These functions make the window visible, and it immediately sends a paint message to the window so it starts rendering its contents. Next, we write a small endless loop to just keep the window open for now. We will change this soon, but for now it's fine. Without it, the program would immediately reach its end and we would not be able to see our window on screen. We can now compile and run our program for the first time. Click on the little arrow next to the play button and select the Run C++ option. We then choose our CLXC compiler. The compilation and linking starts, but we get some linker errors. This is due to some missing internal Windows libraries. VS Code has generated a basic compiler invocation, but it misses two libraries, User32 and GDI32. We add these and the build should now be fine. We try again, and voila, we see our first window. It has some issues though, with message handling, as the freezing blue wheel indicates. We cannot move or close our window, and the name of our window is not fully displayed. Let's fix these issues now. To fix the problem with the missing message handling, we add the so-called message pump. By calling peak message W repeatedly, we tell Windows to pass all the messages for our window to our default window procedure. This enables basic interaction, such as moving the window and closing it with the close button. You may have noticed though, we still have our window title wrongly displayed. This is due to a mishandling of Unicode strings, and we can fix this by passing two compilation macros into our build script, Unicode and _Unicode. If we run again, we now see the correct and full window title. Our window may not look like much for now, but under the hood, it's ready to handle input, redraw itself, and act as a canvas for future graphics. We have built a foundation for our game. In the next episode, we will start drawing inside this window with DirectX 11. If you like this, hit subscribe and join me for the next step.